Hello, welcome to STA 309R session. Today is February 20th, 2018. For today, we have agenda for going over some of the R commands for the project. Um, I will cover just the four commands: tapply, subset, boxplot, and which. Um, so I will first start with setting up the working directory. It's always a good idea to set up the working directory in the beginning of your work. Um, and then I am going to use one of the data that we use for the last year's project. You will not have, you don't have any access to this data, but I'll just use for this today's demonstration. Um, I'm just reading the CSV file, and then instead of, well, I'm going to view the data. Okay. If view the data, we have the days a week and sales, and then this is the number of waters sold per day, drip coffee sold per day, lattes, pastries, milkshakes, and so on. And this is the most popular item of the date, and the temperature, the highest temperature, and the weather of that day. Okay. And if we check the dimension of the data, we have 364 by 12, which means we have 364 days of the data, and then there are 12 categories in the data. So first thing I want to do is to omit the whatever's omit the data that is missing in the data set. So if I just apply the na.omit data, and I'm storing that to the name, the data set as data again. And then if I check the dimension of data, we see that the dimension is not changed. So we can see that there is none missing data in our data set.
What does dimensions tell you again?
Dimensions tell you how many rows and how many columns in your data set. Yes. So the first command, maybe a new command, is called tapply. So what I'm doing here is I'm commanding the tapply for the sales in our data set, and then the day a week and the mean. What it does is, if I run this, it outputs the mean sales for each day a week. Okay. So instead of finding the mean, we can also do tapply data sales data day a week and standard deviation, and run this. Oops. Sorry. Oh yeah. Okay. This is day of week standard deviation. Okay. So we get standard deviation for each day a week. Okay. We can do something else too. If we want the mean sales per each weather, then we can do it this way. Tapply, find the mean of the sales for each weather event. And if I run this, for foggy days, the mean sales was 752. For nothing, or sunny day, 828, and so on. Okay. The next command is called subset. Before we go on, let's look up a help of the subset. So it has x. So it takes 3 attributes, or I'm sorry, 1, 2, 3, 4, many attributes. The first one is obviously the data input, and the second attribute is the logical expression indicating element or row to keep. So for example, if we want to keep some value greater than 10, we specify that such expression in here, and select the column, and drops also do things. Pass on to the bracket indexing operator. Okay. So I'm going to use the subset command here, and then input the data frame we have here. And first of all, I'm just gonna select the columns names as sales and most popular. Make sure you vectorize these two column names, and then run it. And I store this data into a named subset 1. If I open the subset 1, I see the 2 columns, the sales and most popular, which I wanted. We can also do something else. For example, we can mention that we can add something like okay, we can add something like this subset data and add the subset attribute. I'm adding a logical expression. I want the weather event equal to rain, and then find the columns. Adding the column. I'm sorry. I'm trying to find the sales grade equal for the weather event equal to rain, and then find just only the add the columns with the sales and most popular, which contains the weather event named as rain. Okay. So if I run this, I'm storing the subset into a name that's subset 2. Open this. It pops up. It indexes the sales most popular item and the weather event equal to rain. Okay. We can also do something like instead of subsetting the weather event equal to rain, we can do something like find the sales greater than equal to, for example, 800. Okay. If we go back to our data, some of the sales has value smaller than 800, and we want to delete every sales data less than 800. Then we do something like this, and then delete all these. And then run the subset command, and then open that up. We have all the sales greater than 800. Okay. So this is good command is to know to complete your the project. The other one is very simple, box plot. You already know this command. So if we just let's look up the data one more time. We have sales, and the number of items sold, and then the most popular item, and then temperature and the weather event. Okay. One way to view the data is just to create a histogram. If you create a histogram and open it up, so our data is right skewed, has a right skewed distribution. What if you want to know the sales, the side-by-side box plot of the sales for each day a week? So I'm creating the box plot for sales. Sales here you can think of as the y-axis value, and x-axis value are the day of a week. So what I'm expecting to happen here is to find a box plot for the sales for Friday, Saturday, and so on, separately from the data name as data. Okay. If I run this, I get this type of side-by-side box plot. Okay. So for example, on Monday, the distribution is relatively lower distributed compared to like Saturday or Friday sales. Okay. And for Saturdays, we see this many outliers. And by looking at this, we see that, okay, usually the Friday and then Saturday sales are higher than, for example, Monday, Tuesday, or Wednesday sales. Okay, so using the side-by-side box plot is a good way to see how the data is distributed for different indexes. Okay, the last command is called which. So, okay, so let's go through this line first. This is the name of the vector I want to store. And this is the sales, the column they want to use. And in that bracket, I'm adding which the day of the day of week is equal to Friday. Okay? If I just take this one out and then run this, this is the output. It outputs all the row numbers, which has the day of week Friday. Okay? So if I add these vector numbers and then add it to this, and then if I run this and then open the vector Friday sales, or vector Friday sales, it outputs all the sales of the Fridays. Okay, so this is a good way if you want to we'll find a subset of the sales of Friday or Monday, or even for rainy days. So if you do this, instead of vector rain sales data sales which data weather event equal to rain, and then vector rain sales. Okay, this is all the sales of the rainy days. Okay. Okay, thank you for listening, and this is the end of the session.